Pure 3 opens by handing your old algebra a set of power tools. Same job, bigger machines. First surprise, the modulus, those tall straight bars that mean distance from zero. Feed in a negative and it walks back out wearing a plus sign. Graph it, and the part below the axis simply folds upward. In this unit you fold graphs with the modulus, do long division on polynomials, find factors without the slog, split ugly fractions into friendly pieces, and finally expand brackets raised to negative and fractional powers. 5 upgrades, 1 theme. Tame the awkward expression before it tames you. The modulus of x is just its distance from 0, so it throws away the minus sign and keeps the size. That single idea reshapes graphs. Anything below the x-axis gets reflected up, turning a straight line into a sharp letter V. The corner sits exactly where the inside hits 0. To solve an equation like the modulus of x minus 2 equals 5, remember the bars hide 2 possibilities. The inside could be plus 5 or minus 5 because both are 5 units from 0. So you split it into 2 ordinary equations, solve each, and collect both answers. 1 equation in, 2 answers out, never just grab the first. Next, dividing one polynomial by another. It is exactly the long division you learned as a child, only the digits are now powers of x. You ask how many times the divisor goes in, multiply back, subtract, and bring down the next term, chipping the degree down one step at a time, until what is left is too small to divide. Every division lands in the same shape. The thing you started with equals divisor times quotient, plus a remainder. If that remainder is 0, the divisor divides perfectly and you have just found a factor. If it is not 0, you have learned something too, and that leftover is about to become a shortcut. Here is the trick that saves you all that long division. Look again. When x equals a, the divisor x minus a becomes 0, so the whole quotient term vanishes and the polynomial collapses to just the remainder. So the remainder when you divide by x minus a is simply the polynomial evaluated at a. Substitute, do not divide. And the prize case, if that substitution gives 0, the remainder is nothing, so x minus a divides perfectly. A 0 output means a clean factor. That is the factor theorem. Try a few small numbers, find one that makes the polynomial vanish, and you have cracked open a cubic without dividing a single time. Partial fractions undoes a sum of fractions. You know how to add 2 fractions over a common denominator into one ugly lump. This just runs the film backwards. Take that single lump, factor its denominator, and rebuild it as a sum of simpler fractions, each with one factor underneath and an unknown number on top. To find the unknowns, use the cover-up trick. Multiply through, then cleverly substitute the value that zeros one factor, and the others vanish, handing you that constant on a plate. Why bother? Because these simple pieces are far easier to differentiate and integrate later. Partial fractions is the setup, and pure 3's calculus is the punchline. Finally, the binomial expansion grows up. In pure 1 you could only raise a bracket to a positive whole number, and the expansion politely stopped. Now the power can be negative or a fraction, and the moment it is, the expansion never stops. 1 plus x to the power n unrolls into an endless series. But infinity comes with a fence. This endless sum only adds up to the right thing when the size of x is less than 1. Step outside that range and the terms grow instead of shrinking, and the whole expansion is worthless. So always quote the condition, valid for the modulus of x less than 1. No fence, no mocks. Here is the whole unit as one poster. On the left, the modulus folds graphs into V-shapes and always splits an equation into 2 cases. On the right, the workhorse identity of the chapter, any polynomial is its divisor times a quotient plus a remainder, and setting x to a reads that remainder straight off. Underneath, the 2 reshapers. Partial fractions break a heavy fraction into light pieces ready for calculus, and the binomial series expands any power as long as you respect its fence. Master these 5 moves, and most of the algebra mocks in Pure 3 come quietly along for the ride. And the boundary fence, so you do not over-revise. The modulus here stays linear, no modulus inside trig or logs yet. Partial fractions in this chapter avoid the nastiest repeated and quadratic factors until you have practiced the basics. Everything builds on the same instinct. Reshape the expression into something you can already handle.